Hello, everyone. Good morning. The authors and invited guests, welcome to Technical Session 6B. Myself, Ishita Sauryan, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 8th World Conference on Smart Trends in Systems, Security, and Sustainability. The 8th edition of the conference is being organized in a hybrid mode. The physical event was organized yesterday in London, UK, and the virtual event is being held through Zoom from 24th to 26th of July 2024. I hope you will all enjoy the knowledgeable and interactive sessions through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for question and answer. On 10 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I'd like to introduce you all to the chair for this session. We have with us our session chair, Dr. Vijay Singh Rathod, who is a professor, CSE and Director Outreach of Jaipur Engineering College and Research Center, India, and Secretary, ACM Jaipur Chapter, and past Chairman, CSI Jaipur Chapter, having teaching experience of 20 plus years. His core research areas include internet security, cloud computing, big data, and IoT. He has organized and participated 25 plus national and international conferences of repute. We welcome you, sir.
Thank you so much. I'm happy to associate with you all. And should we start the session?
Yes, sir. I'll be introducing our session chair, and then we'll be beginning with the first paper presenter.
Okay, fine.
We also have with us our session chair, Dr. Kanakan Panipong. Sir received his BBA degree in Information System in 2005 from Rajmangala University of Technology, Thaneburi, Pathum Thani, Thailand. MBA degree Business Administration in 2008 and DBA degree in Business Administration in 2018 from Pathum Thani University, Pathum Thani, Thailand. He's currently a lecturer at the Faculty of Business Administration and Information Technology, Rajmangala University of Technology, Bangkok, Thailand. We welcome you, sir.
You are not audible, sir.
Okay, good morning, everyone.
Good morning, sir. Welcome to the session.
We'll be proceeding with our paper presenters. I'd like to invite our first presenter for the session, Kalinka, with the paper titled A Data Model Transformation for Efficient Medical Data Analysis. Ma'am, if you're here, then you may start with your presentation.
Yes, I am ready to start the presentation.
Please go ahead.
May I share my screen?
Yes, ma'am.
Is it visible?
Yes, ma'am, it is visible.
Thank you. Thank you for the opportunity to present our research at your conference. Our research is focused on the data model transformation for efficient medical data analysis. Here is the plan for this presentation, where I will explain the motivation for our research, our methodology, our data, and data processing, and also I will present some preliminary results of our exploration. So today, data is the most valuable resource in the world. It is especially true when we discuss data in healthcare. A lot of medical information is stored now in different systems for different medical providers. And especially valuable is the data that is stored in hospital data systems. So having this data, we can reprocess this data, present this data in a new way, in a new data model, in new applications with new functionality. And also we can approach some different conclusions that will be very helpful for different medical activities, analysis and research, measurement of quality of healthcare, some issues concerning payment, and more activity is in this area. So the aim of this research is to present a possible way for secondary processing analysis of information coming from hospital healthcare. Analyzing this hospital information, developing a new data model will provide an opportunity to improve efficiency, to improve the speed of decision making, and to improve the patient care at all. Let's first explain the role of secondary use of data. Secondary use of data refers to using existing information for purposes other than purposes for its original collection. This data is secondary use is based on data that is already available. This data is collected, this table is organized, is cleaned, and it is more easily accessible. And of course, this saves time and money. Also, this allow to receive new conclusions when new data models are constructed, when new analysis, new scenarios on this data are applied, we can find some new relations and we can reach some additional conclusions. And one more opportunity of using this data again is the time, because this data can be analyzed over extended period of time. In the case of medical data, there are some topics that are of greater importance for all researchers. Of course, this is the patient information of in the first place. This is data with attributes that is available for every individual. This data may have some specific constraint and to require special rights to access it. There are a lot of registry information, names of disease, medicines, doctor specialties, and many others. Registry works in the area of healthcare. Also, a lot of organizational information for different medical providers. Administrative information for patient, for example, patient admitted, patient discharged, the length of hospital stay, and others. And classical clinical data that is extracted from different software application in healthcare, especially from hospital information system. So what is the situation in Bulgarian healthcare? For now, there is no single system that collect, that unify, and enable communication between all systems used by different medical providers in the country. But most of the application of Bulgarian healthcare generate reports to the National Health Insurance Fund. And all these important data attributes that we mentioned before are part of these reports. So these reports can be a good source for analysis. So what was our methodology? We started with analysis of data submitted by the hospital to the National Health Insurance Fund in Bulgaria. We continue with processing and restructuring this data. We create a new data model. We discover new scenarios of data usage. After that, we designed a new application based on this data model and these new data usage scenarios. And finally, we implement this application mostly for research purposes. So here we can see a part of this data model. We designed a new data model that is mostly focused on patient attributes and patient relations with other objects in the healthcare in Bulgaria healthcare area. So as about the new functionality, we focused more on searching by different criteria, for example, patient admission, patient discharges, transfers, clinical procedures, drugs, medicine prescribed. We presented a different view on this data in order to describe different or more specific outcomes of a patient admitted and patient discharged. We created a lot of predefined reports concerning the information about different diagnoses. And of course, we prepared a lot of reports for different periods of times that could use a different set of attributes. Because our new application is most focused on research purposes, in this application, there is no need to support all potential roles of medical workers, for example, medical workers in one hospital. So from this point of view, the functionality is a little bit reduced. Finally, I want to present some example of our first analysis. For example, we can see the number of patients admitted for one hospital for 1 year, 12 months. On the first diagram, we can see that there is a peak of patients admitted in October. This figure presents patient admitted and patient planned and unplanned patient admissions. But on the second graphic, we can see, for example, that we have a drop of planned admission in January. So we can conclude that hospitals are overworked during this period, and probably they will move the most a bigger number of patient admission for February or March. In conclusion, we presented here an example of secondary use of clinical data coming from hospital information systems. On the initial set of training data, we designed a new data model, a new application with a new functionality that was created mainly to be used for analytical and research purposes. And we also show some example of our first analysis over this data. These results cannot be easily reached by standard hospital information systems. This research is part of one of scientific project of Sofia University in Bulgaria. So thank you for your attention.
So thank you so much for such a nice presentation. Is this research completed or not? Is it finished?
I completed, yes.
Okay, you completed. So can you tell me what are the limitations so far in the research that can be improved further?
Yes, we will continue to explore this data because this application was created for these purposes. So we will provide more methods, statistical machine learning methods, in order to find more specific relationships of data in this application.
Okay, fine. Thank you so much.
Thank you.
Thank you, ma'am.
Can we
Thank you,
proceed
sir.
ahead?
Yes, sir.
Yeah.
We'll be going ahead with the next paper presenter. I'd like to invite
Okay.
He
Okay.
Thai with their paper titled Exploring the Frontier Quantum Machine Learning Algorithms. Ma'am, if you're here, then you may start with your presentation. It seems she's not here. Ma'am, He? We'll be proceeding with the next paper presenter in the meantime. Anzeza with the paper titled From Theory to Practice, Applications of Cooperative Game Theory in Economics. Ma'am, if you're here, then you may start with your presentation.
Yes, it's okay. Okay, thank you. Well, let me share firstly, and I hope that it is
Sure,
okay. It's okay?
Yes, ma'am, it is okay. Please go ahead.
Okay, let me open it. Okay. Well, firstly, let me do a short introduction about myself. My name is Aniza Bekoli, and I'm an assistant lecturer, but at the same time, I'm a PhD student in the Agriculture University of Tirana. And this researcher is part of my part of my doctoral thesis that I'm working on, and specifically I'm concentrated in the application of cooperative game theory model in the agriculture sector. But here in this paper, we have concentrated in some theoretical concept about the game theory, but specifically in cooperative game theory, and which are the difficulties about applying the cooperative game theory in real life situation. Well, firstly, okay, can I? Yes, now it's okay. Well, firstly, let me say you a few words and a short introduction about game theory, which is a mathematical framework designed for analyzing competitive situation where the outcomes depend on the action of multiple agents, where each of them has its own preferences or has its own strategies. And furthermore, this model provides tool to predict the behaviors and strategies of individuals or that we are called them players. But which is the foundation of game theory? We know that it is the big John von Neumann, were together with the Oscar Morgenstern in their work Theory of Games and Economic Behavior that they published in 1944, where they have specified that the primary goal of game theory is to determine the optimal strategy for players, to predict the outcomes of strategic interaction, and furthermore to understand the strategic behavior of rational decision other makers. And which are the main elements before going to one of the big branches of game theory? I want to emphasize which are the main elements of game theory, which are the players that are specifically the decision makers in the game, that are the strategy where all the players has a set of action or plans available, and we have the payoffs or the rewards or outcomes that players received based on the chosen strategic and resulting interaction. And one of the biggest concepts is the equilibrium, which is the concept of a stable state where no players can improve their payoff by changing their strategy. Well, two big branches that game theory offer are non-cooperative game theory model and cooperative game theory model. Each of them has its own concept, where the non-cooperative game theory is widely used to analyze competitive scenarios, but is to analyze the behavior of individual players, while to the other part, the cooperative game theory analyze how group of players or coalition can collaborate and form agreements to achieve better outcomes. The key concept of non-cooperative game theory, besides all others, I want to emphasize here the dominant strategy, where it is a strategy that provides a higher payoff for a player where no matter what other players do. While in cooperative game theory, that I want to stay more longer here in this part, we have the collisions. So now we don't have competing between players or between individuals, but we have competing between collision, between a group of players who agree to work together. And the big problem that comes here in cooperative game theory is how to distribute the results that comes from cooperation between members in such a way that all of them remain satisfied. And this big problem is solved from this model by offering two big solutions that this model offers, that are subset solution and one-point solution. Okay, but which are the benefits of cooperative game theory? Also, which are the benefits of applying the cooperative game theory? Starting with the stability and fairness in agreement between players. A cooperative game theory provides mechanism that promotes stability and fairness in agreement between players or between agents. This stability is crucial if we are looking for a situation where we want to motivate the member to be part of a cooperation. The next one is the efficient resource allocation. And as I said before, the cooperative game theory model offers two big type of solution that are two big type of solution that distribute the results between members in such a way that all of them remain satisfied. And from the other part, by allowing agents to form coalition and to work together, and also to ensure to them that the distribution of the results is going to be in such a way that to be fairness for all of the members, they motivate the member in order to be part of the grand coalition. But from the other part, we have that the cooperative game theory simplifies the complex interaction among multiple agents, because instead of analyzing each possibly interaction separately, what it makes, it aggregates preferences and strategies into a cooperative framework. And this simplification makes it easier to model and to solve problems involving many players with diverse interests. From the other part, we have that this model enhances predictability in strategic interaction by providing a clear framework for cooperation. It helps to the other part participant anticipate the outcomes of various cooperative agreements. From the other part, by demonstrating, we are here in the higher predictability, and from the other part, by demonstrating the potential gains from cooperation, this model motivates individuals or players and organizations to work together rather than to compete. And this collaboration can lead to innovative solution and improve outcomes that would be difficult to achieve through isolated efforts. The last part, where we're going to talk a little bit more later in the next slide for more information, we have that this model has a lot of application in real world situation, from business partnership and joint ventures to international treaties and environmental agreements. Its principles can be applied to a wide range of fields, which include economic, political science, and management. But which are some of the real life application of this model? Here I mentioned only some.
Excuse me, can you hear me?
Sorry?
Your slides are not working, I think. We're not able to see your slides.
You cannot see?
No, now we can see. Now we can see. Yes, thank you.
Okay. Thank you that you said to me. Okay. Well, I was talking that I was saying that here I'm going to talk a little bit about the application or the possible application that are done in the literature about this model. In one, not in all, but here I group them, starting with economic and business. This model plays a crucial role in economic and business, which provide tools to analyze and design strategic alliance in business firms where they can form coalition to achieve economic of scale, or share resources, and reduce costs. For example, in supply chain management, there are a lot of applications where companies collaborate to optimize production schedules, inventory management, and distribution networks. The next one is the finance, where this model is used to model and solve problems involving coalition were forming among investors, financial institutions, and stakeholders. The applications in the literature include risk-sharing agreements, syndicate lending, and portfolio optimization. There are a lot of applications in the transportation and logistic. It is highly applicable, this model, where multiple stakeholders must coordinate to achieve efficient outcomes. Where here I can mention the application include airline alliance, where airlines cooperate to offer seamless travel experience, optimize routes, and most of them to share the resources like airport slots. But also in the logistic part, where companies can form the coalitions to share warehousing facilities, transportation fleets, and most of them delivery routes. The next one is the agriculture. I am very aware because I'm studying in the agriculture, so I'm focusing the application of cooperative game theory in agriculture sector. And to be sincere, there are not a lot of application. There are not a lot of application. This is why the reason why I want to go deeper in this field of study, because there are a lot of possibly application where the farmers can form coalitions to share resources such as equipment, storage facilities, and marketing channels. Also, the cooperative game theory also aids in the formation of agricultural cooperatives, where the farmers pool their resources to purchase input, process products, and market them in a collectively way. The next, the two last one are the environmental management. It is used to address issues like pollution control, resources conservation, and climate change mitigation. Also, there are in the medicine, in healthcare, in medicine, where this model helps design and implement a collaborative approach to patient care, research, and resources allocation. Also, hospitals and healthcare can form alliance to share medical equipment. But together with the application, we have a lot of challenging of this application, because it's not easy to adopt a theoretical model in the real life situation, and which are some of the most cited, let's call like this, challenging of this of the application. Starting with the most important one, which is the complexity of this model, because what's happened with increasing of the number of the factor or of the number of the players in this model, it started to be very complex. How it is called, the calculation of the results, because it takes into account all the possible collision. And imagine if we are going to have only 5 agents, for example, this model takes into account to empower 5 collision, and with the increasing of the number of players, they are going to increase the calculation of the results. From the other part, in order that cooperation to be stable, we have to be sure that that at the end of the cooperation, the results that we are going to get after the cooperation to be fair distribute among the members. And this model offers some solution for distribute the results in a fairly way. But what's happened? The fairness can be interpreted in various ways, such as ensuring each participant receive a share proportional to their contribution. But some of them can say, no, I'm not okay with this one. I want more from the benefit that comes from the cooperation, because I have invested in something else and all of this. So it's not easy, and this is one of the big challenges that comes from this model. The next part. So even though the model offers a large number of solutions, that, like I can mention here, the core of the game, the Shapley value, the nucleus. The problem with this solution is the fact that they are very complex to calculate. Yes, they are very complex to calculate, and even though there exists solution that this model offers, they have the problem for the calculation with the increasing of the number of players. The next one is the incentives for cooperation. Sorry?
I'm really sorry to interrupt you, but I'd like to remind you of the time limit.
Okay, yes, okay. And we have the incentives for cooperation, because we want that a coalition not only to receive a higher payoff, but also to the other part to motivate the member in order to be part of the cooperation. And which are our recommendation? Our recommendation, starting with the computational techniques, to have an eye in the computational techniques. There is a need for the development of more efficient algorithm and computer techniques, because this will help in solving large and more complex cooperative games, which enable practical application in real life situation. The next one, we have what we are going to recommend is the fact that developing dynamic and adaptive models that account for changes in player preferences, strategies, and external conditions can make this model more applicable to real life situation. From the other part, this model can be applied to emerging fields such as blockchain technology, renewable energy, and artificial intelligence. And the research in these areas can uncover new applications and provide solutions to contemporary challenges. And lastly, incorporating behavioral into cooperative game theory can enhance the understanding of how human behavior influence cooperation, such as experimental economics and behavior game theory can provide valuable data on player motivation, trust, and decision-making process. And why not, lastly, to develop educational tools and research to teach cooperative game theory can provide its wider adaptation. Okay, and thank you, and sorry about the time. I wasn't aware about the time, but I think that now it's okay.
Yeah, it was truly a very nice presentation, and thank you so much for that. So can you tell me how many references you have used in this paper?
Sorry, how many?
References.
Okay.
Any existing studies?
I don't remember very well. Okay, how many references you mean I used in my paper?
Like to comment on some specific reference related to your project.
Okay, yes, of course, that I mentioned some specific references, but most of them are to the economic and to the business, but to the application of game theory in a real life situation. Because what's happened? From the literature review that I've done and from the working that I'm working on, there are a lot of application of cooperative game, but not in real life situation. And most of them are generated from the theoretical part, because it's more easier to adapt and to generate models from this from cooperative game theory model to generate theoretical model and not real life situation. Because as I said in my presentation, when the number of the player it's increasing, there is a lot of difficulty in calculation the results that comes from this model. This is why there are not a lot of application in real life. I mean, when I'm saying in real life, you are constructed a theoretical model and you are putting as it is in the real life situation. But I'm working on this. We are working on one theoretical model and we want to adapt it in a real life situation, which is very close to the end.
Okay, that's fine. Very good.
Okay, I have a question from this, from the.
Okay, so once again, that your research were implemented to the commercialized products. So I
Was
think you have a
implemented-
good ideas.
No, what do you mean to the commercial product?
So I mean, you implemented or launched the product by your research.
To the sorry, maybe I don't understand the word commercial product.
So I
think
mean,
you have you
Yeah.
implemented in some real life scenario
We
that can be
have
commercial?
we have implemented it in a agriculture supply chain for a special product, but not for how to for a product, only for farmer who produce a product, but it's not focus on a special product, for example, to apple or to orange, or I don't know. So only that produce one product, but we didn't emphasize the fact that which type of product it is, because we are generated a new theoretical model and we're having theoretical results, which means that it can be applied in any other type of product.
Okay, all right.
Okay.
Thank you, ma'am. Thank you, sir. We'll be proceeding with our next paper presenter. I'd like to invite paper presenter Muhammad with the paper titled Implementing a Knowledge Sharing System for Course Development in Higher Education. You may go ahead with the presentation, sir. Proceeding with the next paper presenter, John Jenk, with their paper titled Performance Comparisons of Private AI Chatbot and Public AI Chatbot. So if you're here, then you may start with the presentation.
Okay, thank you. Good morning. So,
Sir John, you may start with your presentation.
okay, so can you guys see the screen?
Yes, sir, it is visible.
Okay, so that today that Pavan cannot come to present the paper, so I'm going to present this paper. All right. So that our paper actually that we like to do some comparison about the AI chatbot, especially that we create a private AI chatbot, and we like to compare with public AI chatbot such as ChatGPT, that kind, to see what's the difference between that if we put the information on the local computer and instead of using these public available ones such as Google's or the Microsoft stuff, and see what's the difference. And so this is our line for today's presentation. So that the basic we like to see what's the chatbot, and then we talk about the system design, and then we do some experiment, and then we conclude, and also that talk about the improvements. This is the chatbot system. User enter some query, and then we will generate embedding that represent the client, the user's input, and then we search the vector store, which is using this embedding, which is generated by the user, and then we find the best match, and that means that it is possible for you to find the top one, the top two, and it really depends on your program and how many matches that you like to return. And then we use this embedding, which is in the vector store, to retrieve the document which is corresponding to those embeddings. And then this document actually is then will then return to the generator to generate the result, which is in here, and actually using the client's input and the prompt, and then generate and then send back to the user. So the whole process is a very simple one. And then the question is, how do we generate the vector store, which is we talking about, which is in here. And so this actually is a very popular way. Firstly, that we split the document in no matter how many documents, and the document can be PDF, a text file, or even the website. And then we split this into chunks. So you, in your program, that you decide what is the chunk size, and they also have allow you to overlap certain text, and then you split into many chunks. And after that, then for each chunk, actually that you embed it into the vector based on the large language model. So you base on the models, and then you embed into these vectors, and then you store this information along with the embedding that into the vector store. Of course, that how do you store this information? Maybe a little bit different depending on what method that you're using. And so, what is embedded? Okay, so that means that we do have a document, but then we then map into some kind of so-called embeddings, and embeddings actually can be used for clustering to search. Maybe in our case we can do that, and then do classification, or even general recommendations, and so on and so forth. So an embedding actually is a numerical representation of a piece of information, such as a chunk of document, say text, document, image, audio, videos, and so on. And the text embedding, which is we are using here because we have a chatbot, and translate the word into so-called meaningful numbers because it's a numerical representation. And then the result, the numbers, usually it's a list. It's a multiple dimensional. It depends on how many is depend on the model. And but this number, if you use that particular model to generate, and then it will give you deterministic numbers, which is an array of numbers. But they do carry meaning because the model make this possible. So the vector determinists and carry meanings, and this is important because of the meaning, so we can generate a meaningful result. Image embedding translate pictures into vectors as well. Okay, in here we say that this is embedded, which is a vector, and that means it's many numbers, and based on categories such as animal, is that what kind of category of this particular one? What is the color? What is the background color? What's the background, and so on and so forth. And so this actually give us this information, And so give a text embedding. For example, we ask some question, and then this text embedding actually can be translated into the corresponding embedding, and then we do the search. And therefore, then you can search the images and so on. And so similar for audio or video embedding. So this is embedding, and different models, they might have a different dimension. As we say, it's a vector, right? So you do have a n dimensional, or no matter how many dimensions, it depends. For example, that for Orama embeddings, that when you use a different excuse me, when you use a different models, they might have a different dimension. Say, Namica embed text have 768, and then for Mistral, which is 4096 dimensions. And we are using that Hugging Face embedding to create embeddings in this project. The model that we use is called all mini LM L6V2. And then this one actually generates 384 dimensional dense vector in this numbers. But this one actually, this particular model will truncate all the input to a maximum 256 tokens. So here we're talking about tokenization and to get each token and then use that token to actually do this embeddings. We also use the phase to store the embedded vector. Okay, so it really depends on how to use store this information, which I mentioned earlier. So we use that. And FAISS, which is stand for Facebook AI Similarity Search. So actually, it's a library that allows the developer to quickly search for embedding or multimedia documents that are similar to each other. And so once again, it's a similarity search, and then the face vector, the store vector as a binary. So they store onto the disk. Okay, rather than the floating point number vector. So this actually is to, of course, is to reduce the storage. And then this is our design. So we create a Flux server. And then the front end design, we use HTML and we use a Bootstrap and JavaScript. And the purpose, of course, is a user friendly and to make sure that it's easy to use. For the backend, that once again we use Flask here to make sure that it's easier to develop. And because as you guys may know that a Flask, which is allow you to set up different service endpoints. And therefore that you can create as many as you want to serve. And as long as that a user know your end service endpoint, the URL, and then they can actually connect to use your system, and therefore it is possible for you to serve many. We use the FAISS information to retrieve the information. For the language model, we use the C transformer to handle query and formula responses, and the backend oversees the interaction with the language model and deal with the context requirement. All right, and so we use the section management to make sure that the user's context actually can be grouped together when you do the response, when you make the response. For the data management layer, the components we use, as we already said, we use the FAISS to establish a vector-based storage mechanism, and they generate the index.
Excuse me, sir. I'm really sorry to
Yes.
disturb you, but I'd like to remind you of the time limit.
Oh, okay. I'm going to go very. Okay, so this is the data management, and then this actually is a user interface. You can create a portal as many as you want. For example, we have the United States Constitution Bill of Rights, and you can have New Jersey's, and you can have your company's stuff. And for example, you like to teach a particular course, such as Python, Java, and so on. You can put those into this portal. You can add as many as you want, so that we can check. All right. And then this actually is a test run. Say I run on Constitution and Bill of Rights. Then you can ask the information. You can ask the questions such as, okay, and how many articles in the Constitution, and so on. And they will tell you answer. Sometimes they maybe answer a little bit different. For example, they might say 7, rather than say, okay, there's 7 articles in this, and so on and so forth. And can you own account, and so on and so forth. All this actually is that correspondent to whatever that you put into there. And we use a PDF file and use a PDF file loader to load this into a system and then chunk them and then store. And these are some performance comparison. Actually, that you can see the time difference. And so when you use the time to actually that use the local and also the using the searching engine. Searching engine is faster, but this is local. All right, so you can see the difference. And so the conclusion is that we actually implement the local AI chatbot and also compare with the public one. And the advantage using this is that we can shorten the query because I don't have to, because when I click on say New Jersey, I don't have to really say, okay, in New Jersey, how many population? I might simply just say, okay, what's the population? The disadvantage is the response time, as you can see from the experiment. And then since the public AI has better response time, then why don't we just use the public the chatbot, such as the OpenAI and so on? So why don't we do that? And the first reason is to prevent leakage of business secret. Say in your company, you might have some data which is you don't want others to see, so you can create your own AI chatbot, which is allow your user to ask questions. For example, that you might have some policy or some regulation, and then you can embed those into your chatbot. Also, that you can customize your local AI beta. You can add the private information, which is actually that if you ask the public chatbot, they may not necessarily tell you. All right. So, what is the future improvement that we can do is how do we speed up? Okay, since that from the experiment result, we know that public AI run faster, and so we can do that, and then the efficiency. All right, and then after that is how do we optimize the chunk size and to make it better? And historical query, this one is a tough one because it's very difficult. At least for it, because unless that you have some information, otherwise you cannot answer certain questions from the public one, even the private the same. We use a CPU, but the GPU and NPU now is very popular. And so, but once again, that we like to see that if we are going to use this one for the general public, which is a use a very cheap laptop, and then actually that it's slower. But now since it's very popular, like NVIDIA, the stock, why the NVIDIA stock is skyrocket is because of the AI. You can create this on your own. And then the efficiency, and we can think about that using the cache. Okay, using the cache to store the question and answer for the quick search. All right, so this is what we think about. And then the optimization is if we don't have those new stuff that build, we don't buy GPUs and so on, we still can tune the chunk size and to see that if this actually can help us to improve the performance, to shorten the response time. And then this one, as I said, that it's a kind of difficult because one of the example which is we did that is here. Actually, we asked the Microsoft Copilot for the name of faculty which is in our department. I'm sorry, in year 1999. And but then they list all the current faculties, and they give us the false information. The information returned is not correct. All right, and this actually happen a lot when you do that. Okay, but even think about that because nowadays people are using agent, right? So you use the agent to create this system, the AI system, which is can help you not just using the one agent, but several. But even with agents, the concept which is built, you still cannot get the information because actually you don't have those information in your hand. All right, so
Yeah,
this is
excuse
actually
me.
the problem. And then
Excuse me.
I-
Can you please conclude because we are running out of time. It's already more than 5 minutes. So please
pardon
conclude.
me.
Yeah, please conclude
Is
this. We are running out of time.
Okay. Sorry. So And then this is the management. How do we do that? And so everybody can upload their AI chatbot onto some repositories such as GitHub and so on. All right. So any question or comment?
No questions so far because we are running out of time. So thank you so
okay,
much
I'm
for
sorry.
the next presentation.
Okay.
Yeah,
Okay.
we can go ahead.
Thank you, sir. We'll be proceeding with the next paper presenter. I'd like to invite paper presenter Rafian Ramadhani with the paper title Self-Service Framework for Hospital Management System. So if you're here, then you may start with your presentation.
Okay, wait, I will share the PowerPoint. Sorry, can you give permission or start?
Yes, sir, you can go ahead.
Wait, yes. Okay, yes. Can see my presentation?
Yes, sir, it is visible.
Okay, thanks. Okay, in this session, I will presentation about my paper about self-service framework for hospital management system. My name is Rafian Ramadhani. And the first, I will tell you about the background of the research. The first, the background is important. How do healthcare service play in role bolstering the population trust in the government in the health service? And the second, the role of IT in Industry 4.0 and 4.5 is a pivotal in enhancing the effectiveness and efficiency of organization or business. And the third is a data security mandatory legal framework for the secure management of personal data specialists in healthcare. And from the three of background, we conduct to develop innovation in health management system. In the literature review, we get first in health management, self-service in the hospital, and third, information technology, and also last is healthcare innovation framework. This the method we develop a design about hospital service management with a design thinking framework is start from empathy. Next, second is define. The third is ideation. The fourth is prototyping, and the last is testing. This I will present about the design thinking process in the research. Before it, I will existing business process in developing system. The first treatment, diagnosis, prevention, education, research, and outsource. And next, I will tell about empathize the hospital service and companies treatment, diagnosis, higher education, research, and outsource, addressing both immediate and long-term health needs. The first is treatment, provide comprehensive care both of patient and inpatient, including emergency service. And the second is diagnosis, dialysis, the radiology for symptom assessment. And the third is prevention, aims to curb the spread of infection diseases. And the fourth is education, involve the patient consultation for better health and management. And the five is research, focus on enhancing hospital management, self customer satisfaction survey. And the last is outreach, extend consultation beyond the hospital serve telemedicine, ensuring compromise to possible at all. And the next step is define. We define about quality. Quality is gap analysis to use gap analysis. QA is quality is gap is QA. Have interaction, information transparency, and registration form. And the cost is cost. And the safety is distress transmission. And efficiency, we analysis gap about business process, and the last is outcome product service. And next is ideation about our research. We conduct the flow about application is start, and next register or login and select service tele inpatient feature or telework feature, tele inpatient to to sleep in hospital, and telework is just work medicine. And next is this design for welcome design for application, and this home. First is login and register, and next is tele in-app design for tele in-app when you sleep in the hospital, and next is telejalan when you just fast in hospital to medicine. And the result, the objective and benefits. The first is enhance efficiency and reduce waiting time. And the second strategy to persistence is comprehensive training for patient and staff, awareness campaign, and involvement of stakeholders early in the development process. And plus testing initiate with trial involving a small group, and trial results show significant improvement in user satisfaction and administrative efficiency. And the feedback and refinement feedback from the trials was used to improve the user interface, enhance data security, ensure seamless integration with existing hospital IT system, and broader adaptation. This facilitated the wider adaptation of technology within the hospital. And the last is the conclusion is self-service, allow participants to access service independently, increasing autonomy and reducing infection risk. And the second is the integration of IT healthcare management is crucial for meeting increasing healthcare demands, improving treatment outcomes, and managing cost effectively, just creating more integrated sustainability and patient-centered service. And the last, the user data within the application complies with health data regulation compliance such as HEPAA, access control in place, and data encryption has implemented to ensure the security and privacy of patient information. There, for my presentation is completed. There are many questions for Mr. or Mrs.
Yeah, thank you so much.
Yeah.
Yeah, thank you so much. I don't have any questions. The other chair, please.
Okay. Thank you for the session.
I have a comment on this presentation, if I can share. Sorry, can you hear me?
Sorry, ma'am, could you repeat, please?
I have one comment for this presentation.
Okay,
because-
if the chair allows, then you can go ahead.
Sorry, please
If the
repeat
chair
the
allows.
You may please ask question, no issue.
Go ahead, ma'am.
Yes, okay. So I have a comment on this presentation. It is very interesting, and I see that there is a tendency more and more services to be moved to the user side in banks, travel companies, now in healthcare. But considering what happens last week with this big IT incident, my comment is that in every case, you should have a reserve backup way to finish the service.
Okay.
You should have paper. You should have assistance by medical workers, because if application is down, what will do the patients?
Okay. Thank you for
So this is my
feedback.
comment. Thank you.
Thank you for the feedback. Maybe we must training of trainer for the application to implementing in hospital in region in Indonesia. Thank you for feedback, Ms. Kalinka.
Thank you. Good luck with the next steps.
Thank you, ma'am. Thank you, sir. I'd once again like to ask for Sir Muhammad Bamban. If you're ready, then you may start with your presentation.
Can you see my screen? Hello?
So your screen is visible,
Okay.
but you're not exactly audible.
What?
You're not exactly audible, like your voice isn't loud enough.
Yes, hello, hello. Oh. Hello, hello.
Yes, sir. It's fine now.
Okay, okay. Thank you, everyone. Good day. My name is Muhammad Bambang Hidayanto, and I would like to present you our research about implementation of knowledge sharing system for course development in higher education. So this is a research that has a focus in XYZ University. For the research background is by the leveraging of the ICT in higher education, we can, what is it? I'll start with firstly, let's address the issue at hand. The rapid development of ICT has transformed the way organizations operate in the education sector. Those like we can say like Moodle, Blackboard, Google Classroom have been made learning more practical. However, this technological brings about significant challenge like integrating the various academic and business process into a single coherent knowledge system that benefit both the organization and the learner. The integration is crucial because academic knowledge focus on learning and teaching activities, while organizational knowledge aims to at achieving business profitability and sustainability. The challenge lies strategically combining this knowledge dimension to capitalize on opportunities and ensure business continuity. The objective of our research is to introduce a knowledge sharing system, KSS, at XYZ University in Indonesia. The system managed by the instructional aims to comply scholarly resources and instructional materials. We will design a procedural flow using the technology available at the front end and also the back end in storing the knowledge, namely materials and content for the learning. This approach aligns with the university strategic plan to digitize content, thereby enhancing business process and creating a more effective learning design. So moving on to the next slide. What is knowledge? Knowledge can be defined as the comprehension of information processed by the individuals of our organization, derived from the experience, studies, and or learning endeavor. So what is KSS? In higher education, it is served not only as a repository of knowledge, but also actively adopt information management practice and learning strategies known as knowledge sharing. So this is institution manage, integrate, and facilitate knowledge sharing among their faculty members, making it significant challenge and a fundamental concept in higher education. This importance is reflected in the allocation of grants to implement KSS practice in numerous universities, especially in Indonesia. So knowledge sharing involves the exchange of experience, even though understanding and any subject matter, with the aim of acquiring additional insight and comprehension that can be capitalized by the organization. And how to implement it, just like I said before, basically they will be a grant by the nation or the organization, and the grant is granting the access to both efficient knowledge held by the organization, valuable basic knowledge that has been captured and made accessible. So we'll try to combine the technology and design the procedural flow of the development of the KSS and also the materials. We'll move to the section technology selection, which features Moodle as the platform. Why? Because Moodle as an educational platform offer significant advantage, and by the literature review that we have been search or the passive search recognize model for incorporating explicit and tacit forms of knowledge, both essential for successful e-learning experience. So in summary, model integration of information and communication technology enhance the effectiveness and efficiency of the education sector by utilizing model as a KSS. Organization can grant access to both explicit knowledge held by the organization and valuable tacit knowledge that has been captured and made accessible as a valuable resource for the organization. This approach ensures the KSS model can greatly benefit organization and their collaborators. So the methodology of this research is using case study in exposure university with the following question: who are the actors? What types of materials that can be developed and gathered, so it can be published into the KSS, and how the process related to the administration, especially conducted by the faculty, and the fundamental activities in collecting the material aligned with the ecosystem in the organization. The fundamental concept behind the KSS in this research is to serve the centralized repository, storing the various data, collection, and information, and it will be transformed into the subjects derived from the semester learning plans or RPS. And the implementation of model as the KSS involves several crucial steps, including defining the organizational structures responsible for its management and utilization, establishing the necessary infrastructure to support the development process, conducting case study through then and its sustainability as a key process. Here is the organization structure. As you can see from the picture, from the figure 3, it is connected by a directorate that is consists to 2 units, and they will establish the support, the online support, and also the content production support. Moving on to the material standard, there are 7 materials that would be developed by the faculty with the help of the unit. So each material have certain purpose that can help the process of learning activity with the hope of equal outcome with the traditional learning in the class. Here is the development process flow. It encompasses administrative phase that serve as deadlines, which involving defining the responsibility of the content developer, reviewer, and the final decision maker to reach the consensus and the comprehensive collection of the knowledge of the subject. So it will start with the process of the role appointment, which the faculty would handle. They would select the teacher or the lecturer as the developer and also as the reviewer. After that, the development team would start developing the materials and publish the materials to the KSS. The process reviewing will come after that, which involves the faculty and also the directorate. After the standard has been fulfilled or accepted, the development will be finished and be delivered as a subject for teaching in the upcoming semester. Here is the results and the finding. Actually, this report were aimed at creating a total of 1,336 subjects with the involvement from all faculty in XYZ University. But within the period of the 2019 until 2023, there is it doubled. By now, it has 3,352 subjects that has been served as the repository for learning purpose. You can see the composition from the faculty that has been created the subjects and also the materials composition. And the video has the biggest proportion. Now the result and findings throughout its evolution, KSS Development Support Unit has made another innovation by organizing training and certification program for the teaching staff. There are two certification named COMS, or certification in administration and of learning management system, and certification in content development, or CETAM. COMS aims to enhance the lecturer's proficiency in operating the KSS and related system for the effective learning implementation at the universities. And second, strive to enhance the lecturer competence in producing online learning content to meet with the standard. So we can observe that the cumulative on lecturers from the various faculties that have been successfully complete the training and certification. But up until today, the certification program have been commercial product and sold to the other university, since it can also provide the benefit of KSS for learning activity, especially delivered in online. So for the conclusion, we can say that the approach to develop and implement KSS with the case study in Exposure University is successful by the number of the subjects that has been doubled from 2019 to 2023, and also the new product that has been become a commercial product from the university. But then the challenge in continuous improvement, the challenge from the the change in the business change, which need to be continuous improvement in terms of updating the standard to meet with the new learning environment. I think that's all from me. Thank you for your attention. I would like to return the session to the moderator, please.
Thank you so much for such a nice presentation.
Thank you.
And yes, we don't have any questions so far because we are running out of time. So let us proceed further.
That was it for the presentations. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 8th version and all the previous 7 versions of the conference. We will be happy to have you in the 9th version in 2025. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have been already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of WS4 2024. I'd also like to thank our session chairs, Professor Vijay Singh Rathod, for chairing the session, our token to chair on behalf of Team WS4 2024 and Global Knowledge Research Foundation. Thank you for your valuable presence, sir. I'd also like to thank our session chair, Professor Kanakan Panipong, for chairing the session, a token of appreciation to the chair on behalf of Team WS4 2024 and Global Knowledge Research Foundation. Thank you for your valuable presence, sir.
Thank you so much.
Before we end the conference, I'd request for everyone to turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe and take care.